Hi there, grade 11s. I'm really sorry that I'm not here today for the first day of school. First day of school is always one of my favorite days. You get to see all the eager students ready to do some math and have some fun. Unfortunately, I'm on my way to Winnipeg. My uncle passed away. I'm going to be attending his funeral. I will be back on Monday, though. So, what we're going to be doing today is we're going to be doing a pretty big lesson. But this lesson is going to cover you for today and for Friday. So you'll get the rest of today to work on it and all class Friday to work on it. What we're going to talk about today is how to graph quadratic functions. And a quadratic function is a function determined by a second degree polynomial. Examples of quadratic functions are y equals x squared, f of x equals x squared minus 5, g of x equals 3x squared minus x plus 5. In other words, a quadratic function is a function that can be written in the form y equals ax plus bx, ax squared plus bx plus c, where a, b, and c are any real numbers, but there's one thing: a can't be 0. Because if a is 0, then that means that we're not talking about a quadratic function anymore. We're talking about simply a line. If the domain, which is all possible x values, is a set of real numbers, the graph of a quadratic function is a parabola. The values of a, b, and c determine where the parabola is located, how fat or thin it is, and whether it points up or down. If the parabola opens up, that happens when a is greater than 0 or positive, the lowest point is what we call the minimum, and it's called the vertex. So this would be the vertex on this parabola, because that's the lowest point on the parabola. The vertical line that passes through the vertex is called the axis of symmetry. So this is the axis of symmetry, and the axis of symmetry cuts a parabola in half. Now, if the parabola points down, and that happens when a is negative, the highest point is what we call the maximum, and still we have that axis of symmetry which cuts the parabola in half. Let's talk about vertical translations. What does that mean? What's a vertical translation? Well, let's say we have a parabola. There's my funky looking parabola. If I have a vertical translation, it means I can move that parabola down, or I can move that parabola up. Moving something up or down is moving it vertically. Okay? So the function y equals x squared plus q represents a vertical translation of q units from the origin on the function y equals x squared. So in other words, if we have something that looks like x squared plus 2, it means we just moved it 2 units up from the origin. Okay? If q is positive, the parabola moves up. If q is negative, the parabola moves down. The vertex of a parabola in this form is 0q. So for our x squared plus 2 here, the vertex, we usually use v to stand for vertex, would be 0, 2. 2 being the q value. Now, graph y equals x squared and y equals x squared plus 3 on the same set of axes. Describe each in terms of its vertex, axis of symmetry, domain and range, and the maximum or minimum value of the function. So, we'll start off by plugging in values. We'll plug in these x values right here into y equals x squared. Remember, when we square a number, we multiply it by itself. So negative 3 times itself gives us 9. Negative 2 times itself, 4. Negative 1 times itself, 1. 0 squared, 0. 1 squared, 1, 2 squared, 4, 3 squared, 9. Okay? Now, let's not graph x squared yet. What I want to do is I want to do this one over here. Then we'll know what our values are, and then we can make our scale. So negative 3 squared, 9, plus 3, 12. Negative 2 squared, 4, plus 3, 7. Negative 1 squared, 1, plus 3, 4. 0 squared, 0, plus 3, 3. 1 squared, 1, plus 3, 4. 2 squared, 4, plus 3, 7. 3 squared, 9, plus 3, 12. Okay, so what we see here is that we see that all the values are positive for y anyway. So what I'm going to do is we're going to figure out what we want here, because basically we have 10 ticks going up and down. So why don't I do something like this? Why don't we say that every 2 ticks is 3 or something? So 3, 6. That's too big. I don't like that. That's good. I'm not going to do it every second. So I'm going to go, that would be 6. And that would be 12. So every single tick is 1.5. So that would make that -6. And that would make that -12. For the x values, we only go up to 3 and -3. So we could even say that every 2 ticks is 1. So every 4 ticks would be 2. So that would be 2, 4, -2, -4. So that could be our scale. And now, using the scale, we can graph both of these parabolas. So what I'm going to do is I'm going to use blue to do this one over here. And so I'm going to do -3, 9. So -3 and 9 would be like right up here. -2 and 4 would be like right here. -1, 3. -1, 3 would be like right here. Why do we do 3? That's a boneheaded move. How about we do -1 and 1? -1 and 1, which would be like right here. 0, 0, 1, 1, 2, 4, 3, 9. So what we get is a parabola that looks like this. And because the parabola goes on forever, you can continue the curve up and down. Okay? So that's what we get for y equals x squared. Now, for y equals x squared plus 3, I will graph this one in red. So -3, 12. So that's like way up here. -2, 7. Which would be like about here. -1, 4, which would be like right here. 0, 3, which would be here. 1, 4, 2, 7, 3, 12. So now we're going to get something that looks like this. And there we go. Okay, so that's what we get when we graph y equals x squared plus 3. Now that we've graphed both of these functions, we can go ahead and compare each of those things it asks us to. So, first thing it asks us for is vertex, axis of symmetry, domain and range. Okay, so vertex, axis of symmetry, domain, range, and now these parabolas point up, so they have, I'll put max, min, but they both have a minimum. Okay, so we'll start off with the first one, the x squared. The vertex would be 0, 0. The axis of symmetry is the line that cuts it in half. Now the line that cuts it in half would be this line that I'm going to draw right here, which would be the y-axis. And the equation for the line that goes through the y-axis is x equals 0. So that would be the axis of symmetry for the blue graph. The domain, well, the domain is, remember how we do domain? We use set notation. So we'll say the set of x's such that x is an element of the real numbers, which basically is a fancy way of saying that x can be anything. Okay, now the range is a little different. The range, the lowest value on the blue graph is right here, the vertex, and that's at 0. So say y such that y, lowest value is 0, so it's greater than or equal to 0. And we should still say y is an element of the real numbers, because that just tells us what numbers make up y. But if we just have, like, x is an element of the real numbers, then that tells us that x can be anything. Now, the max-min value, well, the max-min value is the lowest point. The min value is 0. So the min is 0, which is also the y-coordinate of the vertex. Now, let's do x squared plus 3. The vertex was 0, 3. Axis of symmetry is still x equals 0. That's still the line that cuts the parabola in half vertically. The domain is the exact same, x such that x is an element of the real numbers. The range is different because the vertex got moved up. So y such that y is greater than or equal to 3. Y is an element of the real numbers. And the max-min value, well, the min is 3. And there we go. There's a comparison of the vertex, axis of symmetry, domain, range, and the max-min value for the parabolas x squared and x squared plus 3. Okay? So I'll give you another few seconds to get that down, and then we'll move on to the next example. All right, now we're going to graph x squared and x squared minus 1 on the same set of axes and then do the same thing. So x squared, we should be experts at this one now. That's 9, 4, 1, 0, 1, 4, 9, right? Negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, and so on. Now, the one on the right is a little different. It's x squared minus 1. So basically, you take all those answers we just wrote down in blue and subtract 1. So that's 8, 3, 0, negative 1, 0, 3, 8. So now when we're making our scale, we can make it that what we can do is we can say, oh, let's do this, that we've got, say that's 4, that's 8, that's negative 4, that's negative 8, and as far as the x's go, we'll say that that's 2, that's 4, that's negative 2, that's negative 4. We'll keep the same x scales we did before. The vertical scale, every single tick is worth 1 because it doesn't go above 10, so we'll just stick with that. It'll be a little bit easier. Now, we'll graph both the x squared and x squared minus 1, and then we'll be able to see if we can see the relationship between those properties of a quadratic function that the two have. So, negative 3, 9 would be like right here. Negative 2, 4. Negative 1, 1. 0, 0. 1, 1. 2, 4. 3, 9. So that's y equals x squared. Now we'll do y equals x squared minus 1. So that would be so what we're going to get is we're going to get something that looks like this. It's very close to what we graphed in blue, except the difference is that it's just a little bit down because of that minus 1. It moved the graph down 1 unit. Now, let's go ahead and compare all that good stuff. So, vertex, axis of symmetry, domain, range. Okay. Vertex, axis of symmetry, domain, range, and the max-min value. Okay, so vertex on the blue graph, of course, would be 0, 0. In fact, all this information is the same from the last page. Axis of symmetry, x equals 0. Domain, set of x's such that x is an element of the real numbers. Range, y such that y is greater than or equal to 0, and y is an element of the real numbers. Maximum value, it's a min at y equals 0. Vertex for the one in red, a little different. It's moved down 1, so that's 0, negative 1. However, the axis of symmetry remains the same. The domain, in this case, remains the same. The range is a little different. So this is y such that y is greater than or equal to negative 1. Y is an element of the real numbers. And the maximum value, it is a min at y equals negative 1. So there we go. That is a comparison of the vertex, axis of symmetry, domain, range, and maximum values for the quadratic functions y equals x squared and y equals x squared minus 1. So I'll give you a second to get that down. And then we'll move on to the next example. Okay, so that was what we saw when we had parabolas that move up and down, have vertical translations. Now what we're going to do is we're going to look at horizontal stretching and shrinking. The function y equals ax squared is skinnier or stretched if a is bigger than 1 or if a is less than negative 1. The function y equals ax squared is fatter or shrunk if a is between negative 1 and 1. So graph y equals x squared and y equals 4x squared on the same set of axes and compare them. So y equals x squared. This should be straightforward again. 9, 4, 1, 0, 1, 4, 9. Then we got 4x squared. We just multiply all those numbers by 4. So that's 36, 16, 4, 0, 4, 16, 36. Negative 3 squared, 9 times 4, 36. Same thing with all the other ones. So let's make a scale. Well, we're going up to 36, so that means that every one of these little ticks has to be 4. So that means that 4 ticks would be 16. So what I'm going to do here is I'm going to go 16, 32, negative 16, negative 32. X scale can remain the same, nothing new there, so that's 2, 4, negative 2, negative 4. Okay, so we'll start off with the blue graph. Negative 3, 9. So negative 3, 9 is going to be like right there. Negative 2, 4 would be like right here. Negative 1, 1 that would be like right here. And then 0, 0 would be right there. And then we get something that looks like that. Something would go up to here. Negative 3 would go up to about here. Now if we want to just experiment here, and we want to throw on, say, 4. 4 squared would be 16. Negative 4 squared would be 16. So we could do that just to get an extra point, because we don't have very much that goes up. And that just gives us an extra point, so we can kind of see how this curve goes. But with that, we see that the curve kind of just goes up like that. And then it goes up like that on the other side. So that's y equals x squared. Now for y equals 4x squared, we've got negative 3 and 36, so that's like way up here. We've got negative 2 and 16, so that's way down here. We've got negative 1 and 4, so that's like way down here. And I got 0, 0, so that point is in common between the two parabolas. And there we go. All right, so now let's just join the points. And we see that the red graph is significantly skinnier than the blue graph because of that 4. That 4 makes it so it's significantly skinnier. Okay. Now, once again, it says compare them. Well, what's the difference? Well, the difference is that y equals 4x squared is skinnier. So y equals 4x squared is skinnier than y equals x squared. Everything else is the same. The vertex is the same. The axis of symmetry would be the same. The domain would be the same. The range would be the same. The only difference is the red graph is skinnier than the blue graph. So let's do the same thing here. Let's graph y equals x squared and y equals 1/2 x squared on the same set of axes and compare them. So again, the gimme here is on the left, right? 9, 4, 1, 0, 1, 4, 9. But now on the right, 1/2 x squared. So we're going to take each of those numbers and cut them in half. So 9 to cut in half is 4.5. 4 cut in half is 2. 1 cut in half is 0.5. 0 cut in half is still 0. That's 0.5. That's 2. That's 4.5. So we can use our standard every tick is 1 going up. So that would give us 4, 8, -4, -8. And we'll use the whole, this will be 2, 4, -2, -4, and then just graph our points. So we'll start off with x squared, so that's -3 and 9, so that's going to be way up here, -2 and 4, -1 and 1, 0, 0, 1, 1, 2, 4, 3, 9. And we will connect the dots. There's y equals x squared. Now, y equals 1/2 x squared, we get -3 and 4.5. So that's going to be like right here. -2 and 2. 1 and -1.5. 0 and 0 still. 1.5. 2 and 2. 3 and 4.5. So what we see here is the vertex is the same, but in this case the red graph is fatter than the blue graph. So y equals 1/2 x squared is fatter. So and there we go. Now, what I want to do now is I want to have just a quick talk about graphing versus sketching. Okay? Graphing is something that we do when we are very careful with our points. And you've seen that so far we have kind of been graphing. Okay? We've been plotting our points, connecting the dots, and being very careful about it. Now, sketching is a little bit different. Okay? Sketching is when we don't really care. We care, but we're just not quite as particular. Okay? So let's do this example. Let's sketch -2x squared plus 9. And let's just try and figure out what the vertex is, what the domain and range is, what the intercepts are, the equation of the axis of symmetry, and the maximum and the minimum values. Okay? So -2x squared plus 9. So what I know is the vertex is going to be at 9. So I might as well make my standard graph as far as the grid goes. So that's 4, 8, -4, -8. And I'll even do it same thing here. So 4, 8, -4, -8. Actually, you know what? I'm changing my mind because I can do that. I'm going to make it so that this will be 2, 4, and that's -2 and -4. So let's plot some points here. So we know that that 9 up there is going to tell us the vertex. So we know that that's going to be where it starts. Okay? Now, we don't know much else at this point. We don't. So let's plug in some numbers and see what we get. So let's plug in the old famous, I don't know, let's go -1 and 1. Well, -1 squared, I'll do that over here. -2 times -1 squared plus 9. So that's -2. -1 squared is 1 plus 9. So that's -2 plus 9. So that's 7. So -1, if we plug it in, we get 7. If we plug in 1, I can do it, but really we're going to get the same thing because 1 squared is the same as -1 squared. So we're also going to get 7. So let's plug in -2 and 2. So that's -2 times -2 squared plus 9. And that's going to give us -2 times 4 plus 9, which is negative 8 plus 9, which is 1. So that's going to give us 1 and minus 1. Oopsies, that's also going to be 1. My bad. There's 4 points. That's a starting point. So negative 1 and 7. That's a good starting point. 1 and 7. 2 and 1. Negative 2 and 1. And then we can just kind of just eyeball it and kind of just join those points. So we're going to get something that goes through like this, and we're going to get something that goes through like this, and that's what we get. Okay? So it asks us for the vertex. Well, the vertex would be 0, 9. The domain and range. Well, the domain is still all real numbers. In fact, for all quadratic functions, that's the domain. The range is a little different that we've been used to, because y is now less than or equal to that maximum value of 9. And then we say that y is an element of the range. The intercepts. Now, if we're just estimating here, probably in the neighborhood of like maybe it's somewhere between 2 and 3. So we're just going to estimate plus or minus 2.5. We're not sure right now. We're going to use a graphing calculator later next week, and we're going to be sure. But right now we're not, so we'll say plus or minus 2.5. Now the equation of the axis of symmetry, well, that's that line right here. And again, it's the same line as we've been talking about so far, so that's the line x equals 0. The maximum or minimum value, well, that's a max because it's pointing down, and it would be y equals 9. And there we go. All right? So that's what we can do for a sketch of negative 2x squared plus 9. We're not really as particular about what it looks like. Okay, we're kind of just estimating a little bit. One more example, then it's homework time. A parabola has a vertex 0, 5 and passes through the point 2, negative 3. Write the equation for the parabola in the form y equals ax squared plus q. So we know right here that this is our q. So we know that's y equals ax squared plus 5. And then we'll just plug in the point 2, negative 3 in for x and y. So negative 3 is your y, so it's negative 3 equals ax squared, so that's 2 squared plus 5. We need to bring this 5 over to the left side. When we do that, it becomes negative. So negative 3 minus 5 equals a times 2 squared. Negative 3 minus 5, well, that's negative 8. 2 squared is 4a. So to find out the value of a, we take negative 8 and we divide it by 4. And negative 8 divided by 4 is negative 2. So therefore, the equation is y equals ax squared plus q. And all we're doing is we're plugging in a and q. Well, we already knew that q is 5, and now we just found out that a is negative 2. So negative 2x squared plus 5. That's the equation of the parabola in the form y equals ax squared plus q. Whew. So, for homework, you have pages 109 to 110. It's going to be handed out to you. Do numbers 1 to 63, the odds, 64, 65, 67. That should keep you busy enough for the end of this period and for next period. But if you find yourself with time on your hands because you've zipped through it all, go ahead and do some of the evens. And I will see you on Monday when we do a quiz on this stuff. Have a great weekend.